Bismillahirrahmanirrahim. Today's topic is variable valency. Iron shows oxidation state like ferrous and ferric with 2 plus and 3 plus oxidation states. So iron showing the variable valency. The electronic configuration of iron can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Now, here from 1s2 to 3p6, 18 electrons are to be completed. It is the configuration of argon. So simply we can write the configuration of iron as argon 18, 3d6, 4s2. Writing in terms of 3d, 4s and 4p subshell. Here we can see in 3d there are 6 electrons. In 4s there are 2 electrons. 4p is empty. If 4s electrons lost, we shall get ferrous ion. The oxidation state is 2 plus. So the configuration can be written as, here you can see it is empty. Now in 3d there are 6 electrons, and if 1 electron from this orbital lost, Fe 3 plus would attain, and the configuration can be written as, in 3d there are 5 electrons. So this is the half configuration. It is the half of the 10. So this is stable configuration. That is why ferric ion is more stable than ferrous ion. And due to this stability, the compounds of the ferric ion, they are stable than the compounds of ferrous ion. For example, you can say ferric chloride is more stable than ferrous chloride. Ferric oxide is more stable than ferrous oxide. And also you can say ferrous sulfate is less stable than ferric sulfate. Now, in order to show the variable valency due to the effect of the inert pair of the electrons in the outermost shell of the atom of different elements, taking the example of 1050. So here you can see the nucleus, and we are going outside from the nucleus. Then we are getting 4D, 4F, and here is the electronic configuration of 5s and 5p. In the 5s, there are 2 electrons present, and in the 5p, there are 2 electrons are present. So this 5s is near to the nucleus due to the poor shielding effect of 4D and 4F. So the 2 electron in the 5s show inert pair effect because they are near to the nucleus due to the poor shielding effect of D and F orbital. So the electrons would be attracted more toward the nucleus. That is why they will show the inertness in the bonding and will be reluctant to take part in the bonding during the prevailing condition. So the electron from 5p will get lost, giving 10 plus oxidation state. So imposing new condition, the 2 electron from 5s can lost during a reaction to take part in the bonding. So by loss of the 2 electron from 5s, there would be a result of 4 plus 10. The 10 4 plus we attain by the loss of the 2 electrons from the inert pair. And we always see that 2-unit increase occurs in the oxidation state, because in the inert pair has only 2 electrons. So when they lost, the other oxidation state, the higher oxidation state, as in 10 4 plus, would be attained. Now, taking the example of lead with atomic number 82, the configuration can be written as in the outermost shell, we can write 6s2, 6p2, and also we have the d-orbitals there. We can write for the 82 electrons here like this: 5d10, 5f0, and for 6s they have 2 electrons, 6p they have the 2 electron. Now 5d and 5f, they have poor shielding effect upon 6s. The nucleus exert more attractive force on this 6s electron due to the poor shielding effect of 5d and 5f. So due to this, 6s is more penetrated to the nucleus. That is why 6s show inert pair. Inert pair does not last under prevailing condition, but only 6p can last under the prevailing condition. So if they lost, they are twin number, we will get lead 2 plus, and the configuration can be written as, now you can see here the configuration of 2 plus, the 6p is empty. But here we have still the 2 electron or the electron pair in 6s orbital. So changing the condition, they can also last from 6s to give the configuration of this next oxidation state of the lead, that is the lead 4 plus. Now you can see the configuration here. 4s is also empty, and here p is empty. So by the loss of more 2 electron, we get lead 4 from lead 2. Lead 4 plus is an oxidizing agent, because if it will gain electron from any other species, then it will go to the lead 2. So it's self-reduced and will oxidize the other species. At the last, we see in case of the group number 5, where nitrogen shows trivalency only, but phosphorus shows both trivalency as well as pentavalency. Configuration of the nitrogen can be written as the electronic configuration due to the atomic number 7 is 1s2, 2s2, 2p, 3. For no d orbital is present in the outermost shell of the nitrogen, so nitrogen show covalency of 3 only. But if we see phosphorus, the atomic number is 15. And we can write electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p3, 3d, 0. So this is the outer shell with empty d electron. If only 3 electrons of 3p take part, then covalency is 3. If outer shell, also called valence shell, containing 3s2, 3p3, 3d, 0, utilizes 5 electron by mixing sp and d orbitals. So hybridization like d-sp3 would occur. Then phosphorus will show the covalency of the 5. So these were some cases showing the variable valencies. For example, the attainment of the off configuration, that is stable configuration in case of the iron. And we see the variable valency due to the inert pair effect in case of tin and lead. And we see the case of the variable valency for phosphorus by utilizing the 3p, 3 electrons, and then giving the tricovalency in its compound, and by utilizing the 5 electrons by hybridization of sp and d orbitals, showing the pentavalency. That's all about the variable valency for this lecture.